Many sectors can decarbonize by switching to electricity from renewable energy sources. However, this does not work in certain sectors. These face particular challenges. For example, in the chemical industry and steel production, hydrogen is an indispensable molecule for products and processes. Climate-neutral hydrogen will also be needed to transport renewable energy over long distances, store renewable energy over extended periods, and ultimately strengthen the resilience of our energy system. There is thus an enormous demand for climate-neutral hydrogen in the industry. The global electrolysis market will grow accordingly. This is precisely what we are seeing, particularly in Asia. However, the major challenge still lies in economic viability. Depending on the location, climate-neutral hydrogen is still too expensive. This is precisely where we at Evonik have focused our efforts. In recent years, we have developed a key component that enables more cost-efficient hydrogen production in the first place: our DURAION anion exchange membrane, or AEM. It consists of a high-tech polymer specially designed for this purpose. Global hydrogen demand is already around 100 million tons per year. Various studies indicate that this demand will increase to between 300 and 700 million tons by 2050. However, more than 98% of the hydrogen used today is grey hydrogen. This means that it is based on fossil energy sources. Depending on the production method, at least 10 kilograms of CO2 are generated per kilogram of hydrogen. Based on the 100 million tons cited, this represents a potential saving of 1 billion tons of CO2 today. That corresponds to approximately 1/3 of the energy-related CO2 emissions of the EU. This shows that producing hydrogen without generating CO2 is one of the greatest levers for global climate protection. The preferred method for producing climate-neutral hydrogen is electrolysis. It uses electric current to split water into hydrogen and oxygen. If the electricity comes from renewable energy sources, it is referred to as green hydrogen. However, green hydrogen has so far not yet been available in sufficient quantities and is more expensive than conventional grey hydrogen. In addition to the currently excessive energy costs, established electrolysis technologies are reaching their limits. They lead to either excessively high operating costs because of limited efficiency or excessively high investment costs because of the use of precious metals. At Evonik, we have developed a solution for this: our DURAION membrane. It is a high-performance anion-conducting polymer membrane and the central element of AEM water electrolysis. What makes AEM technology special is that it combines the advantages of existing processes without their disadvantages. In this way, we reduce both investment and operating costs. DURAION is thus paving the way for the cost-efficient production of green hydrogen. Why is AEM technology so superior? First, it operates in an alkaline environment. This allows the use of less expensive materials for the electrolyzer and the electrocatalysts. For example, manufacturers can dispense with costly iridium. This ultimately leads to lower investment costs. And that is a decisive factor for large-scale application. Such applications are being planned and advanced in places such as China, a major market for green hydrogen. Second, our membrane technology enables the efficient production of hydrogen directly under pressure. Because hydrogen is typically used under pressure, this eliminates the need for costly downstream compression stages. Third, AEM electrolysis is highly flexible. It can be quickly ramped up and down. This makes it ideally suited for operation with fluctuating electricity from wind and solar power. Realizing the full potential of AEM technology requires a polymer membrane that is both chemically stable and highly efficient. Until now, such a membrane was not available on the market. Developing it was technically highly challenging. It must combine three contradictory properties. First, it must exhibit very high ion conductivity. This is a measure of electrolyzer efficiency. It must also provide high chemical stability and mechanical strength. This is crucial for its service life. Improving one of these properties typically leads to the deterioration of the other two. Finally, the hydrogen crossover should be as low as possible. This is crucial in preventing hydrogen and oxygen from mixing. Otherwise, an explosive gas mixture would form. This is not only undesirable, but also safety critical. This is why we started our development at the molecular level, with the monomer itself. As a result, our DURAION membrane best fulfills all the properties required by customers. It has another decisive advantage with regard to regulation. We do not use PFAS in the production of our membrane. Throughout the entire process, we drew on our extensive expertise in electrochemistry, material science, and polymer chemistry. We had already applied this expertise in connection with our biogas technology, SEPURAN. In addition to the technical hurdles, there were market-related challenges during development. Especially in the early stages of a new technology, there are either no users or only very few. There are no standards or norms, and all methods must be developed and established from scratch. This means that it takes time for the market to develop. Because of the aforementioned advantages of AEM-Technology, we are confident that it will play an important long-term role in the cost-efficient production of green hydrogen and the ramp-up of the hydrogen economy. To help both the technology and the hydrogen economy achieve a breakthrough, we at Evonik have invested in a pilot plant. This enables us to manufacture our DURAION membrane on a large scale. At just under 20 meters in length, our coating line for anion-conducting membrane is, to the best of our knowledge, the largest in the world. The recent commissioning of our plant also marks a major milestone for us. We have made the leap from laboratory scale to continuous production. This means that, instead of producing our membrane manually in DIN A4 format, we can now manufacture it continuously in a roll-to-roll process and in widths of up to 1 meter. The manufacturing process requires absolute precision. At the start of the coating line, a specially prepared polymer solution is applied to a carrier film. Depending on customer requirements, we can optionally embed a fabric reinforcement. The still moist polymer solution on the carrier film then passes through various drying elements. Depending on how we adjust the drying conditions, we can further modify the properties of our membrane. At the end of the coating line, the dry membrane is wound onto rolls and delivered to our customers in this form. At the current stage of expansion, we are capable of producing membranes for an electrolysis capacity of up to 2.5 gigawatts. This corresponds to 1/4 of the total electrolysis capacity planned in Germany for 2030. So how does AEM-Technology work? The heart of the electrolysis cell is our membrane, shown here in deep purple. The ion-conducting membrane separates the cell into two half cells, the anode side and the cathode side. On both sides of the membrane are the electrocatalysts, shown here in light grey, which enable the splitting of water into hydrogen and oxygen in the first place. In addition, porous transport layers, shown here in dark grey, are required. These transport the gases away from the cell and carry the reaction medium, water, into it. The cell is enclosed on the left and right by metallic bipolar plates. These conduct the electric current into the cell. Many of these cells connected in series form the stack, the central element of the electrolyzer. As soon as current flows, water, H2O, is split at the cathode with electrons, E-, into hydrogen and hydroxide ions, OH-. The hydrogen atoms combine to form hydrogen molecules, H2, which are discharged via the porous transport layer. The hydroxide ions migrate through our membrane to the anode, seen here on the right-hand side of the image, where they are oxidized to oxygen, O2. The electrons generated then react once again with water at the cathode. This results in the two reaction products, hydrogen and oxygen, in high purity. Although AEM-Technology is still at the beginning of its scaling and commercial use, the figures already speak for themselves. Techno-economic studies calculate a potential reduction in investment costs of at least 25% over competing technologies. Of course, there are also competing membranes on the market. However, numerous business partners have told us that our DURAION membrane combines the properties required by the market in the best possible way. Our particular strength lies in complete backward integration, from the starting molecules to the finished membrane roll. This means that, as a chemical company, we can adapt the membrane specifically to customer requirements if necessary. Because we have developed not only the product, but also the entire manufacturing process, we can produce DURAION on a large scale with consistently high quality. Of course, introducing a new product for a new technology is challenging. However, we are confident that we will overcome these challenges because we can draw on our experience in the biogas sector. There too, we have developed a new product family for an emerging technology, thereby contributing to market development at an early stage. As a result, we are now one of the market leaders in the biogas sector. As mentioned, it is currently still considerably more affordable to produce hydrogen on the basis of fossil energy sources. However, the current geopolitical situation in particular shows how quickly international supply chains can become vulnerable. It also highlights the dependence of Germany and Europe on fossil energy sources. The development of a green hydrogen economy is therefore a question of not only climate protection, but also strategic sovereignty and regional resilience. AEM-Technology and our DURAION membrane can therefore make a decisive contribution to building a more resilient energy system. Germany and the European Union still hold a pioneering position in hydrogen and electrolysis. This position must now be defended. At Evonik, we are convinced that this can be achieved. That is why we have taken a first decisive step with the investment in our pilot plant.